Welcome to the explanation of the Chapter 3 Test Review Answer Key. So as we go through these problems, you're going to want to make sure that you follow along with your attempt at the review, correct any problems that you had incorrect along with showing the work, and then you can use your copy of the review as a resource on the upcoming chapter test. So we'll begin with looking at numbers 1 and 2. And remember, anytime we are solving for a variable, we want to get that variable alone, meaning to isolate the variable, by working the order of operations backward. So you always will want to undo addition or subtraction before you undo the multiplication or division. So if we look at number 1, it's 3 times x plus 10 equals 31. So you begin with subtracting 10 from each side. 3 times x equals 21. Divide each side by 3, and x equals 7. In number 2, we have n divided by 5 minus 6 equals negative 8. So you want to undo the subtraction of 6 by adding 6 to each side. N divided by 5 equals negative 2. Undo the division of 5 by multiplying each side by 5, and n would equal a negative 10. Now when we get to number 3, we want to look to combine like terms before we start to undo the math to isolate the variable. So on the left, we have 4k minus 19 plus 1k. So we can combine the 4k and 1k to give us 5k. So the left becomes 5k minus 19 equals 21. So then we want to undo the subtraction of 19. So add 19 to each side. On the left, we're left with 5 times k. On the right, 40. Divide both sides by 5 to get 1k, and k would equal 8. In number 4, we're dealing with the distributive property before we do anything else. So on the right-hand side, you want to distribute the 2 by multiplying it by both parts inside the parentheses. So 2 multiplied by 2x is 4x. 2 multiplied by a positive 9 is a positive 18. So our right-hand side becomes 4x plus 18 minus x. Then we can combine the 4x and the negative 1x, so 4x minus x gives us 3x. So then we have 3x plus 18 equals a negative 15. Subtract the 18 from each side. Negative 15 minus 18 more would give us a negative 33. So negative 33 equals 3 times x. Divide both sides by 3, and x equals a negative 11. In number 5, when you have a variable on both sides of the equal sign, the first thing you want to do is to get that variable to one side. So in this case, I decided to undo the subtracting of 4x by adding 4x to each side. When we do that, we end up with 7x minus 4 equals 10. Then we want to undo the subtraction of 4, so add 4 to each side. And we would have 7x equaling 14. Divide both sides by 7 to get x alone, and x would equal 2. Then in 6, we're dealing with a fraction. So the fraction in this case is 2/5 multiplied by y plus 7 equals 15. You want to undo the addition of 7 first by subtracting 7 from each side. That leaves us with 2/5 multiplied by y equaling 8. So to undo the multiplication by 2/5, you would want to divide both sides by 2/5. Now, we have to remember the rule for dividing fractions. If you're going to divide a fraction, you change the division sign to multiplication, and you flip that second number fraction. So 8 is the same as 8 over 1. So 8 over 1 divided by 2/5 becomes 8 over 1 multiplied by 5 over 2. Then we can cross simplify the 2 and the 8 by dividing each by 2, giving us a 4 and a 1. And then you multiply your numerators. 4 times 5 is 20. 1 times 1 on the bottom is just 1. So 20 over 1, or 20. So y would equal 20. And then we get to number 7. Number 7 is a double distribution before we isolate our variable. So on the left, we have to distribute the 4 to the x minus 9. So 4 multiplied by x is 4x. 4 multiplied by the negative 9 is a negative 36. So that side's 4x minus 36. On the right, we're distributing 1/2 to the 8x plus 20. So half of 8x would be 4x. Half of 20 would be a positive 10. So we have 4x plus 10. Now, I want to start to get the variable alone. So in this case, I added the 36 to each side. So I'm left with 4x equals 4x plus 46. In this case, if we subtract 4x from both sides, because there's a positive 4x, we're left with 0 on the left and 46 on the right, because the variable completely canceled. Can 0 ever equal 46? No, it cannot. So 0 does not equal 46. If the variable cancels and the equation that you're left with is not true, the answer to your problem is no solution. Now remember, if the variable cancels and we were left with 46 equals 46, then your answer would be all real numbers. Then we move down to 8 and 9, where they're asking us to solve for the indicated variable. And really that process is no different than 1 to 7, except now there will be other variables as part of the answer. So when they tell us in part 8, when they say c equals 2 times pi times r, to solve for r. And what this equation actually is the circumference of a circle. Circumference equals 2 times pi times your radius. So we're solving for r, or the radius. Well, on the side of r right now, it's being multiplied by 2 and multiplied by pi. Because that's all multiplication, I can divide by 2 and pi at the same time. So I'm going to divide each side by 2 pi to get r alone, and r would equal c divided by 2 pi. In 9, we have 4x plus 2y equals 8x minus 6. We want to get all our x's to one side first because we're solving for y. So I'm going to subtract the 4x to start to get this 2y alone. So subtracting 4x from each side gives us 2y equals 4 times x minus 6. Then to get the y alone, we need to undo the multiplying by 2. So we divide each term by 2. So each individual term on the right gets divided by 2. So then we have 1y equals 4x divided by 2 is 2x, minus 6 divided by 2, or 3. So y equals 2x minus 3. Now moving to the back side. In a problem like 10, where they want you to write an equation and solve it, my approach is to take the info from the problem first and just underline or highlight what's important. So what we know, it says in Detroit, the temperature is 69 degrees and rising at a rate of 2 degrees per hour. So for Detroit, I know my constant where I started was 69 degrees, and it's rising, so it'd be a plus 2 times my variable. In this case, I used x for the degrees per hour. So x would be how many hours. Then we can look at Atlanta. Atlanta, the temperature was 84 degrees and falling at a rate of 3 degrees per hour. So the falling tells me it's going to be subtraction rather than addition. So for Atlanta, I'd have the 84 degrees minus the 3 degrees per hour change, so minus 3x. Now the question of this is, if the temperatures continue to change at the same rate, how long will it be before these two temperatures are the same? So in this case, we would have 69 plus 2x. So Detroit, when is that equal to Atlanta? Meaning, when are they the same? So you set Detroit equal to Atlanta. Then we can solve for x. So I added the 3x to each side to get all my x's to one side. And we'd have 69 plus 5x equals 84. Undo the addition of 69, so subtract 69 from each side. And 5x equals 15. Divide both sides by 5. And x would equal a positive 3. Now, in a problem like 11, they're asking, what is the better buy? And remember, the better buy would be whichever product is cheaper per ounce or per pound, whatever their unit of measurement is. So in this case, you would want to take the dollar amount and divide it by the number of ounces to get the unit rate of dollars per ounce. So we take the $1.17 divided by the 26 ounces in the jar, and we end up with $0.045 per ounce, or approximately 5 cents per ounce. Then we do the same with the 34-ounce jar. The $1.36 divided by the 34 ounces gives us 4 cents per ounce. So then 5 cents per ounce or 4 cents per ounce. The 4 cents is the better buy. So your better buy would be the 34-ounce jar of sauce. Then we get to 12. It says a truck driver is using 480 miles uses 32 gallons of gas. What is the average miles per gallon? And that tells us how we need to divide. Miles per gallon, the word per is our division sign. So we would have miles divided by gallons. So 480 miles divided by the 32 gallons gives us 15 miles per 1 gallon. Or you could write it this way, 15 miles per gallon in words. I don't care if you write it as a fraction, 15 over 1, as long as you have your units, miles over gallons, or if you write it out in words, 15 miles per gallon. But again, you want to remember your units. Then we get to 13 and 14. 13 and 14 can be solved using proportions, but the approach that I use is to shorten that by a step. So what I look at is, in this case, we're starting at 24 inches and we're converting to centimeters. So in the parentheses, it tells me 1 inch is 2.54 centimeters. So there's always going to be more centimeters than inches. So if I'm going from inches to centimeters and I want more centimeters, it only makes sense to multiply by the 2.54, not to divide. So the 24 inches multiplied by the 2.54 centimeters per inch gives us 60.96 centimeters. In 14, we have 24 divided by 16 because we're going from cups to gallons. 1 gallon is 16 cups. So there's always more cups than gallons. So it would not make sense to have an answer with more gallons than cups, so we would be dividing by the conversion of 16. 24 divided by 16 is 1.5, so we have 1 1/2 gallons or 1.5 gallons. And then on the bottom here, And I apologize, the decimal point didn't show up well on that one, so I'll put it there. So on the bottom, 15 and 16 are converting a decimal to a percent. In any decimal to a percent, you're multiplying by 100 or moving the decimal point 2 spots to the right. So 0.85 multiplied by 100 is 8.5%. The next one would be 0.12 multiplied by 100. Move the decimal 2 spots to the right, and we have 12%. With 17 and 18, we're converting the fraction to a percent. So the first thing we need to do is convert that to a decimal. So top divided by bottom for any fraction. 3 divided by 5 gives us 0.60. Multiply that by 100, and we end up with 60%. And in our last problem, 7/8 to a percent, so 7 divided by 8, 0.875. Multiply that by 100, so move the decimal 2 spots to the right, and we have 87.5%.